Alrighty. So here we have the question, kind of like, what extension mechanisms are successful? How do we do that? I believe, Martin Thompson, you're on the call. One of the questions I had is, there's this document that was started by, that you were working on as part of the IAB on kind of the analyzing this. How do we do protocol extension mechanisms? And there's a set of kind of recommendations here in design principles. And I think this is a really good set to start with. And in general, I think this document is a really useful thing. So I'd love to hear also from you kind of what we think we can do with this document. What are the things that maybe we could add to it, or anything that's changed in the year since this has been updated?
What has changed in the year since it's been updated? Probably not a lot. Well, in terms of the document, at least, the list that I have there is complete as I was aware of at the time, but since then I've thought more about the involvement of extra parties in protocols and the effect that has on ossification. I've written something else on that subject that might be interesting as well.
Okay.
What I would,
which was that? What was?
Oh, I will put a link to that in a second. But I guess the main thing that this lacks is review and feedback from people and understanding what it is that needs to happen in order to complete the set, as it were.
Yep, that makes sense. So I guess, would you be amenable to kind of us adopting this to kind of get it discussed and moving forward within this list and set of people?
Yeah, I mean, obviously, any document that's submitted this way, I kind of feel like if someone wants to contribute, then that's great. I'm kind of at the end of what I can contribute. So if others want to pitch in, then we can probably turn it into something reasonable.
That sounds good. One of the things I know it's just like in here for active use, we talk about that. What is not discussed, and I'm not sure if it's appropriate for this document or for something else, is how do we actually make active use happen in the way that we design our extension mechanisms? Because I've seen, different ways of how you set up your IANA considerations for your particular code points that make it hard to do active use or make it easy to do active use. Is that something that we could discuss more in here?
Yeah, one of the things I've seen, and this may be just my own perceptions, is that there's a lot of protocols out there that have mechanisms that people care about, and they care about them for a variety of different reasons, but they care about that mechanism, and that's the mechanism that continues to work under a variety of constraints and conditions. And so one of the intuitions that was part of Adam Langley's original greasing document was very few extension points. And that's not something that I think people have really taken to heart. If you look at the way that you can extend different protocols, there's often every single possible option under the sun is presented, and that means that then you have 5 or 6 different IANA registries with different trade-offs, with different mechanisms. You choose this one if you want to do this, and you choose this one if you want to do that, and that hasn't, I don't think, worked out that well in the past.
Exactly. And Yeah, I've noticed much the same thing that, we have lots of extension points. Sometimes I think people add them because, especially like, let's say you have like a flags field in some fixed length thing, you don't want to take up the whole thing. You don't need to take up the whole thing for your initial version. And so you have points that you don't even know how you're going to use and they're hard to extend. But other times it just seems like over design and we have too many degrees of freedom. And I think, it'd be useful to have something to say that, you should either have something that's active use or kind of make it an invariant. And you shouldn't have a lot of room in between.
Well, so how do you, like, I see sections 4.2 and 4.3 here is like how you simulate active use. How do you create an invariant without actively using it, right? Like, so an invariant is essentially a specification level contract with future developers of implementations of the protocol, or implementations of part of the protocol in the sense of intermediaries or so. And like one of the things I really like about this document is that it's active use is 0.4.1, right? It's if you want to have an extension mechanism that works, you should have an extension mechanism that works. It's almost a truism, but it's one that, like, at least in sort of earlier protocol design, has been a matter of faith that you create an extension point and then it's an extension point. And really the rest of the points here are about, if you can't get active use for whatever reason, then you should simulate it.
Yeah.
Right. And like, so greasing is one way of simulating it, and cryptography is a way of simulating it even harder. And invariance is just basically you're documenting your threat to simulate it.
Yes.
Right.
I tend to think of the cryptography one as narrowing who you're exposed to, more than the sort of randomization stuff that we're talking about in other contexts. But
right,
it can be used.
Because you can still ossify on the point on the other side of the encryption.
Right.
It just reduces the set of people who can cause a problem for you.
And if you do it wrong, you can ossify on the encryption.
I'm pretty sure we've done that already.
Yeah. So I guess to the larger group, kind of in this context, I'd ask if anyone else kind of has examples that they'd like to bring up of kind of within their working groups, within the protocols that they've worked on. What extension mechanisms do you have that work, like, and does it seem to ring true with, it is the active use that works well? What are the properties of how you actually deal with those extension points? And what are examples of things that were designed to be extensible, but then ended up not being? Watson.
I'd like to add one question there to that, if I could, Tommy. I'd like to hear of any examples of active use failing.
That's true. Yes.
Because we're making an assumption in this document that active use won't, and like it seems true on its face, but
right. Or essentially, like, is there color we can add to the active use to say, like, it's active use, but you have to do it in X way, not Y way? All right, so Watson.
So I'm going to tell you the sad story of the NTP v4 extension fields. So NTP v4 was designed with an extension field mechanism that only got published as an RFC about a decade later. And the implementation had been using them. It squatted the code points from the IANA registry. And what also happened in that time is there were a number of problems with DDoS amplification, UDP-based protocol, and because of all the amplification, people aggressively police NTP packets. So even though the extension fields are sometimes used, Now we're deploying something that actually is going to really use them at scale, and we're finding all sorts of network problems. This is just terrible. It's really, really awful. And on top of that, we kept the format of the header the same for 3 versions. So there are devices out there that will send a packet with a single set bit and expect an NTP response. And as far as we can tell, they're perfectly happy to not understand any of it and just grab parts of the response. So when we come out with version 5, this is going to be a real challenge to get everybody to properly negotiate versions, etc. It's just terrible.
So thank you for sharing that. It was very that's a uplifting story for the morning. So it sounds like, that's a case in which it was not even really explicitly designed and not documented well until much later.
How
Do you see it kind of fitting into, like, how would you describe its downfall succinctly?
so I wasn't there for the creation of it and documentation. My understanding is that it had been implemented in a widely deployed implementation, but the protocol that used that extension wasn't very widely deployed for very good reason. And then when it came time to actually start using it, all sorts of issues started popping up.
So that the primary use of the protocol for a long time didn't have any use of this extension mechanism, essentially.
That's correct.
Yeah. And then all of a sudden it said, hey, we have this mechanism, let's try to use it. And then you just realize that, well, that never would have worked.
No, it's going to work somewhat. Just very problematic, very temperamental, depends on your ISP, and hopefully...
Which essentially makes it, even if you break only 5% of the places, that makes something not really practical for most.
No, it's better than that. There's like a range of lengths that's bad. So eventually you get bigger than that length and it works. And then 4 packets go by and it doesn't work. And then it starts working again. And so you go through the cycle.
Yeah. All right. Thank you for sharing. I think Chris is next in the queue.
Can you hear me?
Yep.
Right, so
Hold on. There we go. Okay, go for it. Okay.
good.
Yeah.
Okay. Yeah. So you were asking about failures, and obviously TLS has these extensions, and they've had mixed success in terms of actually working in practice. Sometimes new extensions do work, sometimes they don't, and sometimes they fail miserably for a variety of reasons, like ESNI's recent debacle being blocked maliciously by China. I don't know if you would classify that as an extension, like a failure of the extensibility mechanism to not like hide itself from that particular adversary or not. So I guess it's not clear to me when you're asking about failures or successes rather, what is the threat model that we're concerned with? Is it just like this dumb anti-ossifying middle box that could potentially be buggy, or is it something more malicious that's actively trying to prevent the use of certain extensions, or just a general extension mechanism?
I think that's a good distinction to bring up, and maybe something that we would want to document, at least. That that gets to the point of what do you put behind that cryptography barrier to reduce the number of people who can do this? Because even if you have active use but people don't like what you're using, they can, that's not really an ossification, that's an attack.
Yeah, but the end result is effectively the same, right? Like
Yes.
you fail to use this new extension. So yeah, I don't know if making that distinction is useful or not. It might be in terms of like guiding which extension mechanism to use. So
TLS is kind of unique in the sense that it provides the encryption. It doesn't necessarily encrypt itself. And so it has this sort of bootstrapping problem that the encrypted client allow is a perfect example of, right? You don't have a prior session, so therefore you don't have crypto keys. And so you end up in this situation where you have to be exposed to all of these third parties.
When you say that, are you distinguishing TLS from Quick?
I wasn't going to get into that. I think Quick has different characteristics, but I suspect that Quick ends up being much like TLS in this regard as well.
Okay, yeah, I wasn't sure if you were, your point was that in TLS or TCP, everything's literally in plain text, whereas in like Quick, the initials are, obfuscated.
They're scrambled.
Yeah, like the keys are known.
I'm not sure how effective that measure will be in the long run, but we'll find out.
I agree.
Well, I think it probably only helps to the extent that a middle box is just a dumb ossifying middle box as opposed to one that's actually intentionally trying to do something with this. But we're probably going to see things beyond active attackers that will say, oh, I will help you by looking at your Quick initial and trying to inspect it. So
Yeah. That's it for me.
All right, thank you. Brian.
So the TLS point is interesting because, and I think I'm going to be annoying transport guy and say we need to treat security special here, because one, there's the physics problem, right? Like, so no matter how we wave our hands around the problem of you can't have cryptographic context before you've shared cryptographic context, right? Like, so that's a hard physical problem that unless we, won't get into that. The other issue with TLS that I think it popped up when Chris pointed out the SNI interception is that there's different models of non-functioning of an extension mechanism that we need to talk about, right? Like, so the SNI non-functioning of that extension mechanism fundamentally changes the security properties of the channel, in that now you know who one of the endpoints is that you weren't supposed to know. Whereas, non-functioning of, sort of, I'll say pre-hipster protocol extension mechanisms was, okay, if I speak this extension mechanism and you speak, or if I speak this extension and you speak it, then we will negotiate it and we'll upgrade. There's something fundamental hiding in the fact that in certain cases, upgrade is sort of this optional nice to have, and in other cases, it fundamentally changes the properties of the channel in an unacceptable way, right? Like, so the use of the words upgrade and downgrade when you talk about downgrade, and then the word attack usually comes after that in a TLS context. I'm wondering if there's something in the physics of these protocols that makes it necessary to treat these cases separately, right? Like, so we can talk about, SNI as an extension mechanism, or we could talk about SAC as an extension mechanism. Are they, like, we think of them as extension mechanisms because it's different bits on the wire, but is there something fundamental about the semantics of these things that means that we should actually use different terminology for the two different things? And this is not me saying, oh, the security thing is hard and I'd rather not think about it. It's the fact that in some cases, the consequences of the failure of an extension mechanism can be widely different. And in some cases, the failure of an extension mechanism can be preferable to have a complete failure of connectivity than the failure of the extension mechanism, right? Like, so in the SNI case, where you're leaking is your interest in a website that affiliates you with an illegal political group, for example. It might be better just to say, you know what, this, failure is the better option. And that's different than in a lot of cases when we talk about sort of like the interference and extension mechanism.
Right. If it's just this is a optimization to make our
and I'm wondering if those are, like, we think of these all the same way because they they manifest themselves in the wire in very much the same way. But I'm wondering if, like, semantically, they're just fundamentally different, and we should, split this into two bugs.
Yeah, I mean, I can imagine other. I'm wondering if those properties are just kind of based on the layer that we're talking about. That, like, okay, transport ossifying is different from security ossifying, and if you have your, HTTP semantics ossifying, or like if your extension's failing to work there, then you aren't able to do this particular application function, and your website's not going to work in this right way, and it's going to look like garbage.
Chris was pointing in that direction in the chat too, right? Like, so the application specificity versus transport specificity, right? Like, so the farther away you get from the infrastructure, the closer you get to semantics that end users care about, and the more careful you need to be.
Right. Things either get more dangerous for their security privacy, or
Right.
they get more impactful of their actual application experience.
I got to think about that a little bit.
Yeah. Colin.
Hi, so just following on from that, are there properties other than security or privacy where we would want to fail if we can't negotiate the extension rather than continue non-extended? I mean, that seems to be the key distinction Brian's pulling out.
Mm-hmm. I mean, it sounds. I would guess that at some of the application level functions, if the entire point of a given connection or bit of communication was to use this particular extension mechanism that allowed me to do, let's say, we're adding, we have ways of doing within H3, we can do unreliable stuff because we're doing some gaming extension. I don't know. I guess we could always design fallbacks that try to use other things. But
Yeah,
at some point,
a lot of
get far
it's,
enough that the application relies on newer semantics.
Yeah, to some extent, it depends whether it's that it works better if you have this extension versus it doesn't work if you don't have the extension.
The problem with SNI is that it does work, right? I mean, you get your connectivity, the information goes from point A to point B, and then it also goes from point to point C, which is what you're trying to prevent with the whole point of the extension. I was trying to think about whether there are other situations other than sort of security and privacy where failure is the better option. And the only one I could think about was the one that Tommy, I think, was thinking about but didn't say, which is where you're building an application whose job it is to test the extension. You obviously want the extension test application to fail when the extension fails. But I am resistant to this idea only because I am very aware of our sort of tribal history of saying security is special, especially in the transport area. And I really want to resist saying that, but it might just be that security is special.
Yeah. Well, and I'm wondering also, like, there is a temporal aspect to all of this, in that my set of things that I'm willing to downgrade gracefully, like every graceful downgrade because the extension doesn't work, has to have explicit engineering work from someone designing what is the downgrade to, and I have to do potentially a lot more work to simulate what I was going to do, or compensate for it. I'm only going to do that back to a version that I believe works very well on the internet and I think is stable, and maybe it itself was an extension point that was created just enough years ago that it's stable and I believe it works. At some point, no one's going to be going back to SSLV whatever, and we're already not going back to TLS 1.0 and 1.1. So if certain things don't work, there's only so far we fall back. And that's, I don't know if that's often kind of documented or made explicit, that when we have these extension mechanisms, it's almost like we want to say, like, these ones work everywhere. You don't have to fall back beyond these. But I don't know. Okay, we have people in queue. Martin?
Yeah, so Watson made a comment in chat that I thought was interesting. I think it's a security point that he's making, but it made me think that about one of the principles in the draft that I wrote, which is if you can't trust the other side to implement a particular feature properly, sometimes it's not worth continuing. So if it's clear that they have not correctly implemented header parsing in HTTP, I'm not going to send them requests with headers in them because that probably won't work. So I'm going to close the connection down. And part of the reason you do that, to Watson's point, is so that you know when something has failed and you escalate rather than just sort of try to muddle by and follow along with the I guess the robustness principle. I will attempt to interpret intent and try my best. Doesn't always get you reliable results. So that's a reason why you might not want to do that. Yeah, Carsten says fail fast.
Yeah,
I think fail noisily was what I was really looking for. But yeah.
Yeah, fail fast and let everyone know that it's bad. Yeah. Thank you, Brian. All right. So I think this is useful stuff. Any other points people want to make here? Any other examples that people want to bring up that would be enlightening for us? All right. Without that, I think we can move on, and yeah, we'll look at the notes from this and discuss on the list about what we want to do with this document and maybe what are the things that we could add or tweak in it, and we'll ask people to kind of review it more holistically as well. Okay, so the other part I wanted to discuss today on the deployability side was kind of, what are the mechanisms that we have within working groups to track our interop, our deployment. If we're doing experiments and new extensions, how do we know and coordinate that we're doing these? And this is something that had been discussed a fair bit on the working group chairs list, and that was a nice big thread. So I imagine people have opinions there. So here, I know we have examples within Quick and within TLS and other areas about how are we doing stuff on GitHub, or different groups use wikis and stuff. But I'd like to hear from this group kind of what are the models that they've done for tracking implementations and interops and deployments, and what of those work well? What are the things that would be useful for your groups going forward?
Wearing something on your head?
Okay. Charles?
Yeah, so I guess my thoughts on this were, and I want to see if it should be treated as part of the same thing or not, but in terms of deployability, just aiding or increasing deployability. So it may not necessarily be code that is implementing the protocol, but code that helps someone with implementing the protocol, like just a library or a test client, or a lot of the types of things that we end up working on in the IETF hackathons, for example. And those things may be long-lived, they may be short-lived, but they kind of help move the protocol forward. They can help someone gain an understanding of the protocol, may help someone with implementing the protocol or adding support for it into their client, their server, whatever it may be. I think those things are not straightforward for people to find in general. Of course, people working in the hackathon can find them, but if hopefully there's links to them on the wiki, but we don't have a consistent way of tying them back to the work that the working group's doing, or even the making it, if you have the RFC, like how are you ever going to realize there's this code associated with it? So that was my interest, and I think it helps deployability and deployment. It doesn't measure deployment.
Yeah,
still in context here, or shouldn't that be a separate issue?
No, I mean, we can probably open up another issue here for that. But it's definitely on the topic that we are looking at, because ultimately, like, I think I'm only interested in tracking deployments and interops to the extent that it helps improve the deployability. So within the hackathon work, because I think that's, you know, one of the best concrete sources of implementation work that we have, and you know, that's where, of course, some of this interop testing goes on. What are the different ways that you've seen people actually link to that? Where are they putting this? Like, is it within like IETF Wiki, other wikis, GitHub, Google Docs? Like, where is this stuff going today?
Well, it's usually in the hackathon wiki, the hackathon for that, the wiki for that specific hackathon. Like we had one for IETF 108, we'll have one for IETF 109. If you go back and look at those, you'll find links to, you know, directly to, say, GitHub repos. Sometimes they're a link to another wiki, and then that wiki has the links to the GitHub repo, or, you know, wherever the code may be. So you can usually find the code that people were working on for all the projects. The other place you find it is in the presentations that they did, which are also uploaded to, actually not in this case, not to the wiki, but to another GitHub repo that we have. So if you know where to look, you can probably find this for basically almost all the projects. But what happens after the hackathon? Are those links still useful? Do people know to go back and look for them? It's, yeah, because it's in multiple different places and done in different ways, we don't have like a set recommendation for how to do it. I'd say in some cases, people will they'll put the code in in a GitHub repo that is perhaps even on the wiki page, sorry, in the data tracker for the working group. And that's arguably a good way to go, but that's not done universally either. And so, you know, as an additional URL you can get to from the data tracker.
Yeah,
perhaps that's a good thing to do. So my thought was just to get people to discuss this and agree on, you know, perhaps a small set of ways that we think these are the recommended or best ways to do it, and then try to get those to be used consistently.
Yep. Colin?
Yeah, I'm just thinking back to when we did this for the RTP spec, when we went from, I guess, from RSC 1889 to 3550. And I mean, I guess things have changed quite a lot in the far too many years since then. But we had an internet draft where we pulled out all of the essential interrupt points and went through and listed, you know, actually wrote down a list of implementations for each one, and whether we'd found interworking implementations or not. And I mean, that was never intended to be published, but going back, I can see if I look in the proceedings from about IETF 50 or thereabouts, the draft and the slides where this was discussed in the working group are all still there. So we at least have a record of how the interrupt discussion worked. So I'm not sure it's desperately useful now, but there is perhaps a case for having the interrupt records in a way which lives within the IETF process.
Mm-hmm. Thank you. Martin, you were commenting in the chat. Do you want to, should we just say this out loud?
So one of the things that I've observed about this is that the protocols that seem to work the best are the ones that have a community develop around them. And so you have a group of people who are all working on implementations and working on the specs, and they communicate with each other. And I haven't found that in those communities there's been any problem with awareness of what people have, where they're up to, any of those sorts of things. There's a couple of things like what Roman pointed out in the chat in terms of reporting about the status of implementation when you're working on something new. But that's just so kind of naturally falls out of all of this.
Yeah. And I mean, yes, of course, yeah, the healthy communities are doing the work. But I think for the discoverability point, like I look at what Quick does with, there's the main Quick web page for the protocol, and it has links to everything there. That is, a far better place to go to if you want to understand what's going on the protocol development than to go to data tracker or anything that's actually, in the IETF page, which I'm not sure that we should kind of have the barrier to entry such that if you want to have that level of clarity and communication, that you need to go figure out how to do that, or if we should have a template for that or a way to make that easier to bootstrap. Rowan?
Yeah, I guess I was what you just said, which is it's not clear to me that we need the interop reports and the implementation reports to be all in the same format. But I think what might be nice from the discoverability perspective, if the data tracker had a standardized way to point to the unstandardized report. So you could go to a working group and it could point to whatever we think we want it to point to, which doesn't have to be standardized, but there's a repeatable and a consistent way to find whatever is written up.
Yeah. Mira?
I only want to very slightly disagree with Martin. So where we have developer communities, that works well and people know where to find things and can talk to each other. But there are also always people who are not part of this community who want to join the community, who develop a new implementation. And especially for Quick, for example, this is this phase where like a lot of people work at the same time in implementations. But if somebody wants to join later, they should still be able to benefit from all the work that have been done there.
Yeah, and I think part of this is overall, and there's a background desire to make sure that we don't have too many silos of communities, that we don't have our IETF protocol documentation being completely separate from people who are actually doing open source implementations or have different groups that are not talking to each other. So yes, for the cases in which it already is working and we have implementer communities that are very involved in IETF and they have their own place to do their work, that's great. But how do people enter that group if they don't know about it? And how do we make it clear that if a working group wants to invite implementers who are not otherwise involved in documenting protocols to be involved in the protocol, how do they do that? Colin?
Yeah, I mean, all this discussion about pointing to external resources, I mean, I think that would be great if we could provide an easy way of doing that. But of course, those resources are not necessarily stable and not necessarily easy to find in the long term. One of the things which we make very difficult for groups is to add resources on the IETF sites. I mean, I guess we have a wiki, but it's pretty clunky and it's not very easy to find. There's no easy way of saying, upload a bunch of Markdown files and they get rendered nicely and it all appears in the site and the chairs and the working group members can easily just keep it up to date and it's somewhere very visible along with all the information about the group. And I sort of wonder if we made it easier to put content on the IETF site, then maybe groups would and it might be easier to find some of this interop information about the way the protocols are being used.
And you're referring to like data tracker as a site for that?
I mean, whether it's on the data tracker or some other sites, I mean, I'm not sure it really matters, but somewhere on ietf.org where stuff can easily get up linked from the pages on the data tracker and you know, wherever we mention the working groups.
Yeah. And Martin's commenting in chat that the TLS wiki rotted pretty fast. Yeah. One thing I was thinking about for data tracker is like the model that we've had more recently for like how people can propose slides or things like that is a lot better also than cases where it just relies on chairs to go and upload and update content. So I think we would also want, you know, anyone, if we were hosting information or links to implementation status, being able to have those implementers be able to propose content into there would be useful. Brian?
Sorry, looking for the mute button. So another thing that I've seen in Quick, I haven't seen in other working groups. I expect that it exists in a few other places though, is actually publicly available endpoints. So implementers will keep a publicly available endpoint for testing up.
Yep.
And this makes sense in sort of the Quick world where everything is happening very quickly, and you know they already had they already had a sort of a cadence of virtual interops even before we all got off of airplanes. And you have the time zone problem, so obviously you want to keep the endpoints up. I suspect that a lot of people in implementation communities of more mature protocols probably also have testing endpoints up for for their own use, and having a way to collect or make those more publicly available. Because there you don't have the problem of a wiki that rots. I mean, you might have a problem of, you know, your publicly available testing endpoint is, you know, 7 revs behind the thing that you're actually shipping. But if you're actually using it for online testing anyway, then hopefully the fact that, you know, it's the code would keep it from rotting as much.
Yeah. I think that would be very useful to have pointers too. Yeah. Also, you kind of mentioned the virtual interop schedule and how that happens on a cadence.
Right.
That's something that also seems like it would fit well. Like we have meeting schedules visible on data track and other things. If we had kind of more support for saying like, yeah, these are our interop times or our calendars for doing other things, maybe that's useful.
Yep.
All right. Other thoughts that people have, maybe any, Robin?
Tommy, can you hear me?
Yes.
Hello?
Yes.
Okay. So in fact, in the routing area, so you know that for our SRv6, we have the draft to record the implementation status and also the interoperability status. I think that's a possible way, but we know that sometimes when the RC is published or the working group is closed, maybe not there's not a way to update this draft or the RC. So I wonder if we can simulate the IPR mechanism, because we know we can disclose the IPR for the draft or the RC. So maybe we can take some tools for the possible users to disclose the implementation or the interoperability test result regarding some draft. So I think they may can update this information at any time.
Mm-hmm. No, that makes sense. And that's one of the things that was discussed on the list. So essentially, I think there are a couple different parts to what you said, right? So like one, like within routing, there's already a practice of documenting in a draft, like here's the implementations section. So we can talk about that, but we can also say maybe does that belong in, or it can either mirror that or move that to a section on data tracker within the document that says, here's the implementation status for it, and have ways of filling that in a stable way. And then that lives beyond the kind of development of the document, and then you can kind of keep updating that even after the RFC is published. Mm-hmm. And then you're saying even kind of decorate, like tools would let you get back to it, or whatever other view of the RFC, right?
Yeah. Because now there's the implemented status. Some is the implemented status always from the co-authors, but that the co-authors are limited. So after they finish the draft of the RFC, maybe later they will not update this section.
Makes sense.
Yeah.
Thank you. So what are people's thoughts and reactions to that? There are a lot of different opinions on if we should, how we should formalize that documentation. Watson?
Yeah, so I think, I'm not sure what the question is about tracking interop and deployment. If it's, these are the servers that are running these draft versions that you can test your implementation and figure out where the draft is unclear during the operation, that's different from curating a list of implementations later. And so I think some of the concerns people are raising about the stability and how do you find it, et cetera, are, it's a short-term thing. It doesn't need to last beyond the publication of the draft necessarily if it's only for the development of the draft.
Yep. And then something that's more like the long-term, like this OS implemented this feature is not something that you need a stable endpoint for. You just want to say like this thing implements this, or this version. Yeah.
So I think I only really know NTP recently. Well, what's going to happen is there's going to be new versions released with NTS, and they'll prominently have that in their release notes.
Mm-hmm.
And people will look there and see what the package does and see what the features are. Whereas a lot of the implementations we're making are not full featured. They're just there to show the protocol works and hammer out bugs in the spec.
Right. And I imagine different groups would find different value in actually documenting or capturing either the development stage of implementations or the kind of deployment stage of it. But having the tools there maybe would be good. Miriam?
I think the thing that we need to concentrate first on is how to find this information rather than trying to standardize this information in a certain way. If we can make it more easy to find, then maybe a kind of pseudo standard or whatever rise, because people get used to seeing it in a certain way. But as long as people don't know that this information exists, everybody just comes up with their own mechanism.
Yeah, and kind of that's just what Martin was saying in chat. Charles?
I think to that point, one of the things I wanted to try was, at least for the next hackathon, let's just try this and let's see for all the projects if we can get links back, that make it easy for you to tell, what working group that project's related to and how to get access to the code. So whether you are on the hackathon wiki or you're in the data tracker, you're able to find out from the data tracker that there's this code that may be useful to you if you're to get that linkage. And then in terms of what the status is, what that code's about, whether it's something applicable to you, to me, that's what the README's for. And, we're not, I don't think all READMEs are updated as they should be over time, especially as code, gets sort of abandoned or degrades or whatever. but to me, that would be the place to say, like, hey, we're not actively using or maintaining this anymore. And then, so even if someone did find an old link, at least hopefully the README would set them straight as to whether or not this is code they're really interested in.
Yeah, that's an interesting point in general about using the fact that we already have the hackathon infrastructure and that going on as the concrete way to try some of these tools out. And in some ways, I imagine, like, if we design something that works well for integrating data tracker documents into what's going on in the hackathon, when groups want to do virtual interop testing, that's essentially just like individual hackathons that is they're essentially running, and we could have it look the same. That's a good idea. All right. Anything else from people? We have a couple more minutes, but we can also wrap up. All right. Cool. So thank you all for joining. Yeah, this is very helpful, and we will continue discussing stuff on the list and GitHub. I think some of the actions that we have coming out of this are, one, to take a look at what we've discussed here for kind of the extension mechanisms and review on the list Martin's document and see what we want to add or send to that and how we can adopt that and progress that. That's one. And then on the other side, I think we do have a concrete thing in which we can look at maybe how can we integrate some tools with what's going on in the hackathon coming up and use that as a way to kind of experiment with having more formal documentation for our interop and deployments. So thank you all. And we'll try to get the recording posted somewhere sometime, and we'll let the list know that. All right. Have a good day, everyone.
Thank you.
Thanks, Dolly.
Thanks.
Okay, bye.